All right, everyone, welcome back for another deep dive. You guys sent in a fascinating article about the ocean's temperature hitting record highs, and let me tell you, it sparked a lot of questions here. We're talking climate change, we're talking oceanography, and believe it or not, even, well, quantum physics.
Quantum physics and the ocean. Sounds like we're going deep, deeper than usual, even for a deep dive.
That's right, and it's going to take us to some unexpected places, that's for sure. But really, there's groundbreaking research happening that's linking quantum mechanics, the super tiny stuff, to how the ocean stores energy. And to guide us through all this, we've got our expert here with us.
I'm excited to dive in. Let's see where this takes us.
So the article you all sent in, it mentions that the global average sea surface temperature hit a new record high of 21.1 degrees C earlier this year, just a few months ago.
Yeah, and that's pretty alarming in itself.
It is, but then it gets even more interesting, or maybe more concerning, when we consider how all that heat is actually being stored.
Exactly. And that's where our current understanding kind of hits a wall. Because the rate at which the ocean's warming and storing all this energy, it's exceeding what our climate models predicted. So clearly, there's got to be something else going on, some piece of the puzzle we're missing.
And that missing piece? Well, it seems to be coming from the world of quantum physics. Specifically, the work of this Professor Geoff Smith from the University of Technology, Sydney. He's proposing something called a quantum thermal physics paradigm. I mean, even the name sounds intense.
It is, but it's also really fascinating. Basically, Professor Smith is saying that we need to think beyond just heat when we're talking about how the ocean stores energy.
Okay.
He believes there's another form of energy involved here, something that operates on a much, much smaller scale at the quantum level.
Okay, hold on. Before we go any further, let's maybe unpack this quantum energy thing a little bit, because I think most people have a grasp on heat, but quantum physics, that's a whole other universe.
Right, and that's what makes this research so groundbreaking. Professor Smith suggests that energy is also stored in the ocean in these things called photon-water molecule pairs.
Photon-water molecule pairs. It sounds like something out of Star Trek. What exactly are these pairs?
So imagine a photon, which is basically a tiny packet of light energy, and it gets all tangled up or entangled with a water molecule. And they become this sort of duo, a coupled system that can store energy differently than heat does. It's a natural form of what we call quantum information.
Quantum information. Is that like the stuff they use in those quantum computers everyone's talking about?
It's a similar idea, but not exactly the same. Think of it like this. Computers we use every day, they store information in bits, which are either a 0 or a 1, right? But quantum information, it can exist in multiple states at the same time. It's like it can be both a 0 and a 1 at the same time, which means it can hold a lot more information, be much more complex. And in this case, these photon-water molecule pairs, they're storing energy in this quantum way.
Wow, so these pairs, these tiny energy bundles, they've just been in the ocean all along, doing their thing.
Exactly. And Professor Smith's research is suggesting that they actually played a role in keeping ocean temperature stable, kind of acting like little energy buffers.
Oh, interesting.
Absorbing any extra heat and helping to keep things balanced.
Okay, so I think I'm starting to get the picture, but here's where things start to really boggle my mind. If these pairs were helping keep things stable, why are they now part of this accelerated warming we're seeing? It's like they switched sides.
It's a great question. What Professor Smith's suggesting is that the extra heat in the atmosphere, because of those greenhouse gases, it's somehow changing how these photon-water molecule pairs work. They're getting more active, and instead of absorbing the excess heat, now they're actually releasing it, which adds to the whole warming effect.
So it's not that they're against us now, but the rules of the game have changed.
You got it. And we're still trying to figure out exactly how this new game's played, what the new rules are.
Well, that definitely complicates our understanding of climate change. And if Professor Smith's onto something, what does this mean for our current climate models? I mean, they're built on a totally different set of assumptions, right?
That's a big concern. Absolutely.
Yeah.
If these models aren't factoring in this quantum energy storage, then their predictions about, say, how much warming we'll see in the future, they could be way off. And if our predictions are wrong, then the strategies we come up with to deal with climate change, they might not work either.
Yeah, it's kind of like trying to use an old map to get somewhere new. You might think you're on the right track, but if your map doesn't show all the mountains and rivers...
You could end up lost, yeah.
Exactly, totally lost.
Okay, so that's a great analogy. It really drives the point home.
Yeah.
So if we're working with climate models that are basically using incomplete information, where do we go from here?
Yeah.
How do we start incorporating this whole quantum thing into all of this?
Well, that's where things get exciting, I think. Professor Smith's research, it's like opening a new door.
And it leads to a whole new understanding of how the ocean works, how it stores energy, and how it all interacts with the atmosphere.
So we're not just talking about tweaking the models we have now, but maybe creating a whole new framework for understanding how these incredibly complex systems work.
Exactly. It's going to take a lot more research, a lot more data, and, scientists from different fields need to work together. Physicists with oceanographers, climate scientists, people who build the models.
It's a huge interdisciplinary challenge.
It is.
And it's a challenge that has, it's got real-world implications, right? This isn't just some abstract theory we're talking about. We're talking about the future of the planet, our coastlines, our weather patterns.
Absolutely. Because the more accurate our climate predictions are, the better we can be at preparing for and mitigating the impacts of climate change. If we can really figure out how this quantum energy storage works, maybe we can develop more accurate models and make smarter decisions about how to protect the planet.
That makes sense. So this brings us to the so what question, You send us this article, you're clearly interested in this stuff, but how does it all connect back to, to you, to your life, to our listeners' lives?
Well, that's the cool thing about science, isn't it? It often starts with something that seems, totally abstract, like quantum physics and the ocean. But then it has all these ripple effects that can impact every part of our lives.
I like where you're going with this. Can you give us a concrete example?
Sure. So imagine we're able to refine our climate models to really account for this quantum energy storage. This could mean that our predictions about things like sea level rise are much more precise.
Okay.
And that kind of information, it's super important for coastal communities that need to plan for the future, for governments investing in infrastructure, for insurance companies trying to assess risk.
Right. So something as fundamental as understanding how energy is stored in the ocean, it could actually help us make better decisions about how we build our cities, how we protect our coastlines, how we plan for the future.
Absolutely.
Yeah.
And that's just one example. There are probably tons of other implications we haven't even thought of yet. That's what's so exciting. This is really just the start of a whole new area of exploration.
Yeah. Wow. I can't help but think about all the research that's still to come. Where do we go from here? What are some of the big questions that scientists are going to be trying to figure out in the next few years, decades?
Well, for one thing, we need to really get into the nuts and bolts of how these photon-water molecule pairs interact with all the extra heat coming from the atmosphere. Like, what's making them release more energy? How are they impacting ocean currents and how heat gets distributed? These are tough questions that need really sophisticated experiments and observations.
So we're talking about scientists really diving deep into the quantum realm of the ocean, trying to unlock all these secrets.
In a way, yeah. And it's not just about observing. We also got to figure out how to actually incorporate this quantum behavior into our climate models. That's a massive challenge, computationally speaking, but it's essential if we want models that accurately represent the real ocean and how much energy it holds.
So a lot of work ahead for the brilliant minds in science, for sure. But what about the rest of us? What can we do with this information? Most of us aren't, quantum physicists or climate modelers.
That's a good point. But I think even though this research might seem, way over our heads, the key takeaway is the importance of staying curious, of asking questions, and of always trying to learn more about the world around us, even if it seems complicated.
Yeah, it's a reminder that even when facing something as massive and challenging as climate change, there's always more to learn, there are always new discoveries to be made, and there's always hope that we can find solutions if we keep pushing the boundaries of what we know.
And sometimes those discoveries lead us to some pretty wild places, like the quantum world, hiding right there in the ocean.
Yeah. You got that right. It makes you realize how much is still out there. About our own planet, all the ways that everything's connected. It's incredible. Okay, so we've covered a lot of ground here today, from record-breaking ocean temperatures to this mind-bending world of quantum physics. But before we go, let's try to bring it all back to our listener who sent us that article. What's the big takeaway here?
I'd say the most important thing to remember is that the way the ocean stores energy is so much more complex than we thought. There's this whole other level, this quantum layer that we're just starting to understand.
And that understanding, it could really change how we model the climate and how we deal with climate change.
Exactly. It shows us that science is always evolving, always making new discoveries. And sometimes those discoveries mean we have to rethink everything we thought we knew. Humbling, but also pretty exciting.
It is exciting. It reminds us that there's still so much left to explore, so many mysteries to solve. The ocean's like that, vast and deep and full of surprises.
Yeah. Yeah, I like that comparison. And who knows what other incredible discoveries are waiting for us down there.
Well, on that note of wonder and possibility, I think we'll wrap up this deep dive for today. A big thank you to our expert for guiding us through these uncharted waters.
It's been a pleasure. Really fascinating stuff.
And to our listener who sent in that article, we hope this gave you a new way to think about the ocean and all the mysteries it holds. Keep those questions coming and keep exploring. And join us next time when we dive into another fascinating topic. Until then, happy diving, everyone.